theorem. Suppose that the GCD of B and D, and the GCD of A and B, and the GCD of C and D are all equal to 1. So B and D are relatively prime, A and B are relatively prime, and C and D are relatively prime. And the question was to show that AD plus BC over BD is in lowest terms. And of course, that's the fraction A over B plus C over D after obtaining a common denominator. To prove this theorem, we're going to suppose that I have a prime factor of the denominator. If I have a prime factor of this denominator, b times d, I need to show that it is not a prime factor of the numerator, a times d plus bc. So if something goes into the denominator other than 1, I must show that that number cannot possibly go into the numerator. If I do that, then the numerator and the denominator are relatively prime, and I'm done. So if p divides b times d, then we have a theorem that says that either p divides b or p divides d. So I've got two cases. Let's treat these cases separately. So case 1. Suppose p divides b. If p divides b, then clearly p divides b times c. So p will be a factor of that part. So to finish, I need to show that p is not a factor of this part. So if p divides b, p will be a factor of this portion, b times c, and I need to show that p cannot be a factor of a times d. Well, we have got this assumption about the GCDs. The assumption is that the GCD of b and d is equal to 1. Also, the GCD of a and b is equal to 1. So if p divides b, and b and d are relatively prime, so if p is a factor of b, that means that p cannot possibly be a factor of d, because b and d are relatively prime. So p is not a divisor of d. And the little vertical line with a slight line through it is supposed to mean p does not divide d. Also, if p divides b, and a and b are relatively prime, that means that p cannot possibly be a factor of a. Now we have another theorem. If p is not a factor of a, and p is not a factor of d, then p is not a factor of a times d. So we've got a scenario where p is a factor of b times c, but p is not a factor of a times d, and therefore p is not a factor of the sum. So p is not a factor of the sum ad plus bc. So that's case 1. If p divides b, then p cannot divide ad plus bc. Case 2 is going to be similar. If p divides d, then p divides a times d, and then I proceed as similarly to show that p cannot be a factor of b times c, so that once again p does not divide ad plus bc, using pretty much the exact same logic. So either way, if p is a factor of b times d, then p cannot be a factor of the numerator ad plus bc. And so we conclude that AD plus BC over BD must be in lowest terms. And so we cannot simplify that any further than it is.